Hello everyone, in this video we will be solving problem 3330, find the original type string 1. The problem statement is we are given a string word which represents the final output displayed on Alice's screen when she is typing, and we need to return the total number of possible original strings that Alice might have intended to type. It is possible that Alice might press a certain key for too long, resulting in the character being typed multiple times, but it can only happen once. For example, if Alice is trying to type A and B, it is possible she might type the character B for too long, resulting in the output having multiple B's. So we are trying to identify all possible original string that Alice might be trying to type. One more constraint that is given to us is this mistype can happen at most once. So it can either be no mistypes or at max one mistype. Looking at example number 1, there are two possibilities where Alice might have mistyped, one with character C and one with character B. As Alice can only make one mistype at the most, the total combinations possible are 5. I hope you are able to understand the problem statement. It is very easy and straightforward to understand. Now let's switch to whiteboard and discuss the solution. Let's use this as our example. Here there are two possibilities where Alice might have mistyped. One is with the character E and the other is with character L. Let's try to solve this problem using brute force. In this approach, we'll try to identify all possible combination of the word we can build, starting with the first character H. This is a good use case where we'll try to build a graph with H as the parent node. As the next character E appears multiple times next to each other, H will have two possibilities or two legs. One is where we'll use E as is, and the other is we'll use HEE. Both of the E's will be included in the string. As Alice cannot make more than one mistype in the entire string, if we assume that she made a mistake with two E's, the remaining characters in the string should be taken as is. So rest of the characters or the word will be HELLO. While on the other leg, it is still possible that Alice made a mistake. Repeating the same cycle of identifying if the characters are being repeated, the next character is L and the one after that is also L, which means L is being repeated twice. Applying the same logic here, one combination will include both of the L's and the other combination will have only one L, and then adding O to both of them will give us the final strings. So we identified a total of 3 combination of words. First one is hello, the other one is HEELLO, which is the original input, and the third one is HEELO, where we have 2 E's and 1 L. I hope you are able to understand how we broke it down into this graph and tried to identify all unique combinations. With this solution, our time complexity is going to be O of n, where n is the number of characters in the input string. This is because we are trying to identify all possible combinations using a single pass and trying to build this graph. While the space complexity is going to be O of n, as we are building these words at each level or depth until the traversal is complete. As we don't need the actual words and instead need to know the total number of words we can build, let's think of optimizing this solution which can improve our space complexity. Let's try to identify a pattern between the graph that we built with the original input word. Every time we see or encounter a duplicate value or multiple occurrence of the same character, we are adding more legs to the parent node, thus increasing our output. For example, because we have two E's in the input, in the graph we had two legs for the parent node H, where the first leg only includes one E, but the other leg includes both of the E's. The same pattern can be observed when we were iterating through the character L. Because we had two L's, there was a split at node E with two legs, one with single L, the other one with two L's. Based on this logic, we can infer that our output will be the total number of characters that are equal and consecutive to each other or that occurred in the word. This logic is only possible because we know that Alice will not be making more than one mistype in the given string. Let's do a short dry run to understand this approach. Let's start with I is equal to 1 as we will be comparing the current value with the previous value in the string. With I is equal to 1, the current character is E while the previous character is H. As it does not match, we'll leave the counter as is. By default, the value of the counter will be 1 as the original string can also be a valid one. So considering that assumption, the output or the counter will always start with 1. Moving on to the next value, if I is equal to 2, the next character is E, I minus 1 is E. As they both are equal, we'll increment our counter to 2. Now let's assume that we only have 3 characters in our word and this is the last call. With the word containing H, E and E, there are a total of 2 possibilities that we can build. One is with H and E, no multiple E's in it, and the other combination is the entire word as is, H, E and E. With this combination, the output is going to be 2, which matches our counter value. Moving on with the iteration, with I is equal to 3, the current value of the character is L, the previous is E. As the two characters do not match, the counter will stay as is. And moving on with the iteration, with I is equal to 4, the current character is L and the previous character is L as well. As they both are equal, we'll increment our counter by 1. The new value is 3. With I is equal to 5, the character is O, the previous character becomes L. They both are not equal, the counter stays as is. After we are done with the iteration, we'll return the counter as our output. With this solution, our time complexity stays the same, that is O of n, as we still need to iterate through all of the characters in the input string, but the space complexity is improved to O of 1 as we are only using two variables. One is the pointer to point at the current character and the other is the counter. I hope you are able to understand this explanation. Let me show you how we can implement this using C#. In the C# implementation, I've initialized a variable base that will be our output or the counter. After that, I'm starting a for loop to iterate through all of the characters in the input string starting with I is equal to 1. I'm comparing the word that I is pointing with the previous word, that is I minus 1. If the two characters are equal, I'm incrementing the base counter by 1. Once the for loop is complete, I'm returning this base, that is the counter, as my output. This code, when submitted on LeetCode, beats 65% of the submissions in terms of runtime and 94% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.